Uh, okay. Do you guys want to discuss now, or do you guys want to have more time? Any problem? Okay, no problem. So whenever you guys want me to discuss, please tell me. Just take your time. What are even number? Only even number. The answer sheet is only for even or for odd number?
For odd number.
Oh, for odd. Okay. What do you think? It's too easy or too?
I think it's a little bit difficult.
Okay, no problem. So maybe 3 minutes from now, I will discuss. But it's okay. I think the problem is quite interesting to solve. That's why. Okay, let us discuss the problem. Okay, I think most of you for the first problem, eh, you guys can solve that. So we just doing quite quickly. So we multiply this with, maybe we don't use that sign now. So we'll multiply with this, the conjugation of the divisor part. So it's equal to limit x approaching to a of fx minus fa over x minus a times square root of x plus square root of a. So okay, I continue here. So it is equal to limit x approaching to a fx minus fa over x minus a times limit x approaching to a x approaching to a square root of x plus square root of a. So it's equal to fx, the derivative of f in a times 2 square root of a, right? So far so good. And well, believe it or not, the second problem is not harder than the first one actually. So let us do this. So this one is equal to what? X to the power of 46 plus x power 45 over 1 plus x plus 2 over 1 plus x, right? So this one is equal to x, well, 45, uh, 1 plus x over 1 plus x plus 2 over 1 plus x, right? So it is equals to x power 45 plus 2 over 1 plus x. Let us call this one hx, and this one is 2gx. Why 2? Because I will derive this without 2, which make our life easier. So basically we know that f to the power of 46 of x is equal to h, uh, no, sorry, the 46 derivative of f is equal to 46 derivative of h plus 2 of the 46 derivative of g, right? Okay, so far so good, right? Now, what is the 40 46 derivative of x, of h, sorry? Any answer? Well, that's the easy part because this one will be equal to 0, right? because hx is equal to x power 45. So in the h of 45, what we have is 45 times 44 until times 1, and the x is power of 0. So this one is equal to 45 factorial. So it is a constant. So when we derive a constant once again to 46, it's become 0. Okay, so this is the easy part. Now, uh, let us do the gx. So we know that the gx is equal to 1 over 1 plus x, or 1 plus x power of minus 1, right? So the first derivative will be minus 1 times, well, this is actually a composition, uh, the rule of composition. So you can have the inner first or outer first, but the inner one here, because this is only x uh, power of 1, so the inner one is 1. So yeah, we can write it here 1, but I don't think we need to write that. So minus 1, 1 plus x. This one is minus 2, right? Well, if you like, you can write down as something like this. Minus 1 over 1 plus x squared. Square. Sorry. Square. Square. Now, how about the uh, second derivative of g? It's also quite easy. We have minus 2 here. So minus 2 times minus 1, we have 2. 1 plus x over minus 3, power of minus 3. Or we can say that this is 2 factorial times 1 plus x minus 3. Okay, so we can see the pattern. If it is the number is even, there will be positive. If the number is odd, it will be negative. So we proceed. G over 46x will be 46 factorial times 1 plus x minus 47. So far, so good, or I make some mistake here and there? I think good. I think so far so good. So if you find me doing mistake, please let me know. So now we have the derivative, the 46 derivative of fx is equal to 46 derivative of h plus 2 of 46 derivative of g. So this one is, because this one is 0, 0 plus 2 times 46 derivative of x, which is this. So 2 times 46 factorial over 1 plus x to the power 47. So the answer will be just, well, 2 times 46 factorial over 4 pa- power of 47. Well, what? Okay. So far so good, or I make mistake, or there is something you confuse so far? No? No, right. So, okay, good. So my point in this exercise, and I think Prof. Iman also did in the class, and last week, last week when I do this kind of, what? You remember there is a problem like this. The first one is to show you that more o- more often than not in the calculus class, the the hard part is not the calculus itself, but the algebra. So, well, how to say? Uh, Maybe you need to exercise and more for the this kind of algebraic trick, because I don't think I can teach everything because there are so many there out there. But why h, the 46 derivative of h is 0? Because h is x power of 45. So let me show. Okay, okay. So, sorry. Let me show you something easier. Let's say j, x equals to x squared. Sorry, x to the x power 1. What is the j, the second derivative of x? So the first derivative of j is 1. The second derivative of j will be the derivative of 1. So d1 over dx, but 1 is constant. So that, well, it is constant, there is no difference. So everything constant, so the rate of change is 0. So the derivative will be 0, right? Now we can see that if we derive the derivation number is higher than the polynomial number, which is here 1, but we derive twice, the answer will be 0. And so far, and also G3, J4, J100, all will be 0. So here we have hx equals to x to the power of 45. So everything that, uh, if we derive h more than 45 times, we will get 0. Is it clear, Jordan? Or a good question, because look, what is the main difference between h and g? Anybody want to have opinion? What is the main difference between h and g? Anybody want to answer? Try to answer? No? Okay. The main difference of H and G is H, for the H, here the H, the power is positive, while for G, the power is negative. So let us imagine that from from if the positive number when we derive so many times, when it's achieved zero, then it's will become zero all the way down. But if it is negative, it's when we, because derivation is just like power minus one, right? We, so the power doesn't go into zero, but on the reverse sides. So they go to the minus infinity basically. So yeah, that's why G doesn't become zero. G 46 time derivation doesn't become zero, although it's only minus one, right? G is power of minus one, but well, it's just become minus 47 basically. Is it clear for you or not? Okay. So that's the main problem of f is of the original function is the power is composite. So we have a positive power and also negative power here. So that's why I go to this road to separate between H and G, because the to separate between positive power and negative power. So when we have positive and negative power separately, we it's much easier to deal with. Okay? Okay, good. I think it's quite clear. Hmm. Well, we have, I think, 8 minutes left, right?
Yes.
Well, so I don't think we have time much more, but uh, well, okay. The first part is just a composition, uh, a rule of composition in action. So I think you can do by yourself. The second one is quite important because I think some of you have learned this trick. It's called Lopita Rule, right? I think in Taiwan you guys have learned that in the high school, right? No, the I don't know in Chinese, but in English, basically they call it this Lopito.
Probably.
Basically, say this. So and it is a quite nice trick, but uh, warning first because it's easy, right, to do. But if in the exam you have a limit problem, never use Lopita rule unless the problem say you can use Lopita rule. Why? Because otherwise your grade can be zero in that problem. So the teacher will thinks that you don't understand the limit. You just know the L'Hopital trick, basically. So don't use this rule unless the in the problem they say, have you learned that?
This one.
Yeah, that one.
Uh,
No,
maybe. I'm not sure.
not sure. Okay, not sure. Sure, this one, this one. So it's I think it's interesting to see this in action. So let us do this. Limit of x to the 0, f x. Well, I do from right to the left because I think that it's easier to do. Derivative of x over g derivative of x. Hmm. This one is equal to limit x to the 0, limit h to the 0, uh, f x plus, well, basically we just use the definition of derivative, plus h minus fx over x minus h over gx plus h minus gx over x minus uh, gx over x minus h. Well, I will rewrite so it's easier to read. Fx plus h. Sorry. Limit x approaching 0. Limit h approaching 0. Oh, I forget. Usually when we want to prove from right to left, we write the symbol, so a row from right to left. Fx plus h minus fx over x minus h and x minus h over gx plus h minus gx. So we can see that we can simplify this problem. So it's become here limit. Well, I switch between h and x, but not a problem because both are approaching to 0, right? So x approaching to 0, f x plus h minus fx over gx plus h minus gx. But we know that f0 and g0 equals to 0, so this one is equal to 0, this one is equal to 0, so that's become limit of x0 limit h approaching 0, f x plus h over gx plus h, which equal to the left part. Okay, so I think that's quite interesting part, and sorry for mess, but uh, basically I want to show to you guys some very what I personally think interesting trick in calculus, that when how they derive it. And I think if you are interested, please Google Lopita Rule, because Lopita Rule is quite first it's quite useful trick. Second, it's the drama behind the invention of Lopita is quite interesting. You can make movie out of it, because actually the inventor is not Lopita, but Bernoulli or some else that, and Lopita pay for him. Okay, I think I think that's all for today. Thank you very much for coming in this tutorial, and see you next week. But if you have something to you come, if you want to ask something, yeah, you can ask me now if you want. But otherwise, thank you very much. See you. Repeating it.